Welcome to the walkthrough for Assignment 1A in my CS 891 course in the spring of 2023. The purpose of the first part of this two-part assignment is to acquaint you with developing a synchronous microservice with Spring WebMVC. In particular, in this assignment, you'll develop a synchronous microservice that uses Spring WebMVC to return lists of objects containing information about movies from a movie recommender system we'll use throughout this course. The code you write for this assignment does not have a GUI and runs as a Spring application with an automated test program. Please feel free to use this test program to help debug your solution. The following resources may be helpful in completing this assignment. An overview of Spring WebMVC appears here. Professor Jules White has a YouTube playlist with an excellent overview of Spring WebMVC. Naturally, we'll cover this material in class, which will be available in my YouTube CS891 playlist. The Movies microservice is packaged as a project using IntelliJ. This app is written in Java and demonstrates various Spring WebMVC features. For the purposes of Assignment 1, however, you only need to be aware of the following directories. Recommender Movies, which contains the skeletons you need to fill in, as described below, and Movies Source Test, which is a set of unit tests that exercise the features you'll be implementing to evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you need to use the provided IntelliJ project. You can run this project by clicking the green arrow next to the Movie Test drop-down menu in the IntelliJ IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Do not change the overall structure of the skeleton. Just fill in the to-do tasks and don't delete the to-do markers. In particular, you need to finish implementing the following to-do tasks for this assignment in the following files and folders. moviescontroller.java, where you'll need to complete the to-do tasks and various fields and methods to define endpoint handler methods that return lists of objects containing information about movies. moviesservice.java. Here, you'll need to complete the to-do tasks and various fields and methods called by the movies controller to return lists of objects containing information about movies. Components.java. In this file, you need to complete the to-do tasks in factory methods, known as beans, that can be ejected into Java classes using the Spring auto-wired annotation to load a dataset containing movie titles and descriptive vectors. And finally, movies-sync-proxy.java, where you'll need to complete the to-do task to implement various proxies to various endpoints in the Movies microservice. Your solution should strive to use no loops or if-else statements in this assignment, and instead use Java sequential stream aggregate operations and Java functional programming features. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. Skeleton code for this assignment is available here in my GitHub repository. Please set up your GitLab account, pull the skeleton code into your repository, read it carefully, and complete the to-do markers. The unit tests in the Movies Source Test folder are provided to increase our collective confidence that your implementation is working as expected. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the unit tests to detect problems in your code. Assignment 1A is designed to acquaint you with developing synchronous microservices using Spring WebMVC. The skeletons in your tests are subtle, though you don't need to understand them all to complete your solution. Please start early and ask questions in class, office hours, and on the discussion forums to ensure you complete this assignment successfully. Now that we've talked about the specification, let's walk through the skeletons in the Assignment 1A project. This is my IntelliJ project. I've opened it up, you can see, and inside there's a folder called Movies, and it has a subfolder called Source, and that subfolder is divided into yet further two subfolders called Main and Test. We'll start by taking a look at Main. So we take a look here, there's two subfolders there, there's Java and Resources. The Resources folder is given for you. It contains a file that describes the port number that this microservice listens on, and it also indicates where to find the data set containing the information about the movies, and it gives the microservice a name, which is called Movies. Here's the actual data set. I'm not going to spend a lot of time talking about this right now. You'll get more familiar with this as the semester goes along. This is just a very large list of about 4,800 movie names with then encodings of various properties about the movies. For example, who the director is, who the cast is, what genre is the movie, what language is it in, so on and so forth. And we'll use that when we get to the recommendation portion of the class. Let's skip through that for right now and take a look at the interesting part that you have to work on, which is the main Java edu Vandy recommender movies folder. As you can see, there's a bunch of files here that are Java files, as well as a subfolder called model, which contains a record that gives the description of the movie title and vector and how they're stored and returned from the Movies microservice. And as you can see here, the movie name is identified as a string, and the movie properties are encoded as a list of doubles. And not surprisingly, that list of doubles corresponds to what's in this movies database file. And we'll take a look at that in a little bit more detail as we go further along. Okay, so let's go ahead now and take a look at some of the interesting files here. Some of them are provided for you, some you'll have to implement yourself or fill in the blanks yourself. We'll start with the movies application file. This is essentially the main entry point for the movies application microservice, which has a bunch of methods that return a list of objects containing information about the movies. As you can see, we've provided an annotation here, which is a @Spring Boot application annotation that indicates to Spring to do some automatic configuration and component scanning and dependency injection and auto wiring and so on based on this application class, which is really the microservice application. As you can see, there's a main method which just turns around and says, hey, Spring, run this application and do all the various wiring and dependency injection and management and so on. So this file is given for you. You don't have to think about it any further. Let's take a look at a file you actually have to be paying attention to, which is the movies controller file. And this is the Spring controller for the movies service. And the endpoints handler methods that are defined here all return a list of objects containing information about the movies. As you can see, there's further annotations. There's the @rest controller annotation, which indicates to Spring that this is going to be used to create a so-called restful controller, which is a specialization of something called a component. And it automatically enables Spring to detect class path scanning, and it figures out essentially various things about wiring all the pieces together that are part of this particular controller portion of the code. We have a couple of fields defined here. One is given to you called the application context, which is a central interface that provides configuration information for this microservice while it's running. Don't have to worry about that. It just needs to be there. There's also a field you'll have to complete, which is the movie services service field. And we'll talk in a minute about what a movies service is. But for right now, we define a field, and you have to add an annotation here that informs Spring to auto-wire this movies service field with the movie services or movie service implementation here. So you have to add that little annotation. Ignore the info method for now. This is something we'll do in a later assignment. Let's now take a look at some of the methods you have to fill in. The first one is one that's going to return a list of all movies. And to implement this, you're going to have to create an endpoint with an annotation that will map HTTP GET requests onto an endpoint handler method for the all movies or get all movies constant. And this particular method will take no parameters and will simply forward to the movies service get movies method. And you can take a look here and see what that method looks like. This will give you a hint as to how to fill out what this movie controller endpoint handler method needs to be. It'll need to be a little bit more than what's in the movies service because we have to provide the annotation that indicates to Spring how to map incoming HTTP requests with this particular path in it and get that to the appropriate controller endpoint method here. You'll then have to go ahead and implement another method, which is going to search for movie titles in this in-memory database that contains the given query string. So this method will be passed the search query as a string, and it'll return a list of movie titles that contain the query that are represented in movie object form. Remember, these are the movie objects that we talked about before. And I'll talk about how you get that in a second. You'll have to write an endpoint here with an annotation that maps the HTTP requests methods, or rather requests, onto a handler method for the search or get search parameter. This is going to be also using a so-called path variable annotation parameter, which we'll talk about when we look at some of the examples shortly. And it will forward to the movies service search method that takes a single query string. The third and final method you'll have to implement here will be used to search for movie titles in the database that contain the given string queries. So we'll actually pass in a list of search queries. And you'll get back a list of movie titles that contain the queries that are represented as movie objects. Once again, you'll have to write an endpoint with an annotation that maps HTTP GET requests onto a handler method for these searches or the get searches constant, which is the path portion that indicates which method we're looking at. And this will use the requirement of a request parameter so we can pass it a list, and it'll forward to the movie services search method that takes a list of query strings. So you have to fill in those methods together with their annotations. And that takes a little bit of thinking, but of course we'll walk through examples to make it more clear. Here then is the movie services class, which defines all the implementation methods that actually do real work. And the movie's controller calls these methods to return these lists of objects. Once again, we've added an annotation here, which is a Spring service annotation that enables Spring to be able to automatically detect and wire the dependent implementation classes using class path scanning. And as you can see, the first thing you're going to have to do here is add an annotation that will connect the movies service to the list of movie objects. And these are going to be coming out of this components file. And we'll talk about what's in the components file here in a moment. The particular thing we want to get called here is this particular method, which should be annotated to become a bean, something you have to do. And you'll then have to fill out the implementation of movie list to return the appropriate list using something else we'll talk about in just a second. So this will get auto-wired. When you watch the videos about auto-wiring and dependency injection, you'll see how that all works with Spring. Down here, you can see the getMovies method. This, of course, is what's going to get called by the appropriate corresponding method here in the controller. And what that will do is you'll write the code here that simply returns the list of movies, which should be really simple because it's sitting right there. So this code is ridiculously easy. Let's take a look at something a little bit more complicated, which is the search method that's going to be passed in a single query. And what you want to do here is you want to write some code using the Java sequential streams framework to go ahead and walk through the stream of movies and find all the movies whose ID matches the query and then return them as a list of movie objects. So this will return a subset of the total list of movies. And I recommend you use the contains method on string and you lowercase everything appropriately so that it'll do the appropriate comparisons. So you have to replace null, return null with the proper code. And then the third and final method implementation you'll have to provide is the search method that takes a list of queries. And this is a little bit more complicated, although if you use streams, it's pretty cool and you can do it very concisely, actually very much similar to the code that's up here. And so you'll basically convert the list of movies into a stream. You'll filter out the ones that don't match, or another way to look at it is you accept the ones that do match, the queries that are passed in here, and then you'll go ahead and create a list of results and pass that list of movie results back to the client. So those are the things you'll have to do for movies service. The other thing you'll have to write here is the implementation of some of the component bean factory methods. So I provided you with one here, very simple, but you'll have to make this a bean, which is also very simple. So you'll have to make this movie map method into a bean, and then you also have to make this other movie list method into a bean, and you'll have to write the implementation to do what's described here, where you basically have to use the movie dataset reader, which is this piece of code here. You can read it at your own convenience. It's super duper cool. And it opens up this movie dataset file and will parse it and then return it as a map that contains the string movie names and then the list of doubles that correspond to the movie property encodings. Again, don't think too much about what we're doing there. We'll talk about that later. So what you have to do here is you have to go ahead and essentially load in the data set, movie data, and then you're going to have to convert that into a list of movies. And once again, I recommend you use a Java stream. It makes it quite simple to do this. And down here, you have to do yet one more thing. You have to add the appropriate annotation to get the get movies REST template bean to work properly. And this particular method is actually used by the test program, and we're about to go look at the test program now. So we finished looking at all the to-do markers you have to do for the actual microservice implementation. Now let's go overhead and take a look at the test, which will essentially make sure all these things work properly. So here's the movies test, and this is essentially something that's called a Spring Boot test. And when you watch the next part of the video where I show you how to run the test, you'll see how this essentially goes ahead and creates the movies application microservice automatically, and then wires things together and sends it requests. To do this, we're going to auto-wire a couple pieces. We're going to auto-wire movie sync proxy. We'll talk more about that in a second. And we'll also auto wire the list of movies, which are going to come out of the components portion over here. And if we go back over there, the movie sync proxy, that's what you're going to have to finish implementing. We'll talk about that in a second as well. But let's go take a look at movies test. So I'm not going to talk a lot about this. This is kind of intentionally designed to be a little bit hard to read because I don't want people using it for their implementation blindly. You should do a much better job. This code is intentionally not written in the most efficient way. But what it's doing is it's going ahead and it's calling the movie microservice, getting the list of movies and making sure the expected size is what we received. There should be 4,801 movies in our database. We then go ahead and are going to get the movie list and then check to make sure that what you return from your implementation matches what we expect. Again, I won't walk through that in detail. And there's a bunch of other methods that check to see. We're going to look up all movies that have the word star in them, and there should be 33 of them. And we're going to take a look and then find out what those movie names are and make sure that they match. And then finally, we're going to make ourselves a list of movies that have Trek and War in them. And then we'll make sure how many of those we get. There should be 65 of those. And then we're going to get all the movie contents and check to see if they match. So once again, don't get too wedded to reading this code. It's not really meant to be read. You should do a much better job of writing this code using Java functional programming and sequential streams. Let's now go over here and take a look at what you actually have to write. So the code you're going to have to write here is the part of the movies sync proxy that will create the appropriate URL to indicate the appropriate endpoint in the movies microservice, and then make an invocation to call that particular request on that microservice to get a result back. So down here, you're going to have to fill in the code that uses the URI components builder factory method class to make a URL to the all movies endpoint of the movies microservice. That's what goes here. And then you'll go ahead and write the code that will use the movies REST template, which we see up here, and the web utils make get request list helper method in order to get a list of all the movies from the movie microservice. And that code will go there. And for each of these things, you'll have to write the code. They're all very similar, but they each have to deal with different types of parameters. In some cases, you'll have to, for example, pass in the query parameter here for the search movies. It takes one result or one parameter. And then down here in the search movies that takes a list of queries, you'll have to do some additional magic down here in order to be able to convert this list into a string. And to do that, I strongly recommend you go over and take a look at the utils web utils class. This is a little helper class that I wrote that makes all this programming way easier once you take the time to learn how it works. And it's got a couple of methods you want to get familiar with. Make get request list, which takes in a REST template, the URL that you create, and then the class that corresponds to the return type that's coming back, which will typically be an array of movies. And it does all the work to actually make the call and convert the results into a list. So get familiar with that. That'll save you a lot of headache if you understand how that works. And then there's also a very interesting method here called list to string. And you pass in a list of things like a list of strings, and it goes ahead and turns them into a single string of comma-separated subparts. So take each element in the list, and it turns it into a comma-separated string of results. So these are some things that are going to come in really, really helpful when you write the code here to do the proxy logic. Now, I'm providing you with structure here so that you can kind of figure out how to do this in a paint-by-numbers-like way. And the good news is that when you start using this kind of technology in practice, you'll either do something along these lines and make it very straightforward, or you'll use some other higher level mechanism such as retrofit, which will actually generate all these proxies for you automatically. I'm having you do the code here by hand just because I want you to get accustomed to seeing how it works. So we will go through some nice examples in class that illustrate how to write proxies, and I will walk you through a bunch of examples that are similar to this one. So hopefully it'll be straightforward by the time you finish your implementation, how all this stuff works. But be aware that, honestly, some of the most complicated code here is getting these proxies to be correct. And that's one of the things you'll discover when you work with Spring and other mechanisms that are based on HTTP. There's some boilerplate code that's just a bit tedious and error prone. And so the best way to deal with it is to encapsulate it in a wrapper class like movies sync proxy, and then have your main code just make method calls onto the proxy, and thereby shielding the fact that there's any kind of network or remote computing taking place whatsoever. So that's the end of the walkthrough of this particular skeleton set. You'll get a lot more experience as we go further in the class, taking these concepts and going in a lot more deep directions. So this is just a starting point to get you acquainted with how to write kind of client-server code using Spring WebMVC and synchronous communication. Now that we've walked through the specifications and skeletons for assignment 1A, let's go ahead and take a look at how to run the unit tests. In order to do this, you simply open the project, complete the various to-do markers, and then you go ahead and select the movies test option or configuration from the drop-down menu up here, and you click the Run Movies Test button. And this is a green arrow that you click, and that will go ahead and compile the tests. And assuming everything is working properly, after all the tests are compiled, they'll go ahead and actually start to run. You can see the tests are running. They're a total of 6 unit tests that check various aspects of your solution to make sure it's working correctly. These are all what are known as black box tests, and they won't actually check the internal structure of your solution. They'll just see that you created the right output. And assuming everything goes well, then the tests will all have a little green check mark. You should make sure that all your tests have a green check mark. And if you don't have a green check mark, then you need to come to office hours and or ask questions on Piazza or in class to make sure that you can get your solution working properly. So the very last thing I want to cover in this walkthrough video is what you do after you're done with your implementation and you've run the tests and you're about to submit your solution for the initial review. What I want you to do is come along and take a screenshot of the results of running the tests. So here you can see I've done a little screenshot. It shows up down here on the bottom of my screen. If I click on that, it comes up. This is on a Mac, but you can do the same thing on Windows. And I want you to take that results file, and I want you to go ahead and commit it to your assignment 1A folder. Put it in the top level, so it's at the same level as things like the README file, and it should be a file called results, all caps. So I want you to go ahead and save that file in a file named results, and I want you to go ahead and add that to your GitLab account, and I want you to go ahead and push it when you push all your code. And I will take a look at that file to make sure that you've actually run the unit tests. If you do not run the unit tests and you do not put that results file in that folder showing what you've done, your program will not be graded. So you will receive 0 points for the entire thing. And so it's very, very, very important that you do this. I will talk about this many times in class. And so I want to make sure that everybody's completely aware that in order for your code to be reviewed and graded, you have to have the results file here in your root folder of that project of assignment 1A.